Hello, it's almost 10:50 Eastern, so we have two short presentations about activity in learning analytics from two projects, Shuhari, which is still in the Apereo incubation process, and OnTask, which emerged from that process earlier in the year. These are two short films because the presenters couldn't be available, one of whom lives in Australia, so that's understandable. It's the middle of the night there. There are limits to this synchronous stuff. Wilma, could you run the video?
Sure. Let me just pull it up here.
The last 7 years we've been involved in the Open Apereo Learning and Analytics initiative. We call it Shuhari. Shuhari is all about storing data for analytics and for reporting, and then visualization of that data. And that's what I want to show you today. So thank you for coming to my talk. So today I'm going to go over the Apereo Learning Analytics Initiative. I'll give you a little bit of history. Then I'll take a quick technical dive into the OpenLRW, which is the data storage component of our initiative. And then we'll talk about the enhancements that we can add to the LRW. And then I'll show you the visualization component of the initiative. We've been working on this for, like I said, about 7 years, I guess. So we started this in about 2013 or 2014 with Apereo, and with the help of University of North Carolina. They made big contributions to the LRW and the dashboard. That was under the direction of Lou Harrison and subsequently Jeff Webster. The University of Notre Dame made contributions to the LRW, and the University of Lorraine out of France, they did as well. I think I say dashboard there, but I meant LRW, and I'll explain all that in just a bit. I'm going to give a special mention to Marist College because they developed a lot of the analytics and risk scores for consumption. Now, the Open Analytics Initiative doesn't actually produce analytics in and of itself. That has to be done by someone else, and in this case, that was done by Marist University. So the code base to get you started is out in the Apereo Learning Analytics Initiative GitHub. You can pull it down. There's 3 components, really 2 functional components, but the dashboard is broken up into 2 different projects. I'll explain why in just a second. The LRW, which is the Learning Record Warehouse, that's the you can think of it as a data store for events and for rostering and stuff like that. That's available at Apereo/OpenLRW. You can pull down the API and UX for the dashboard. They're separated so that someone else can come along and create their own front end if they so desire. But they all connect. They all talk to each other. So the goals of the Open Analytics infrastructure was to allow collection and storage of a variety of data. So we wanted to be able to store rostering information. We wanted to be able to store event information, just deciding on what type of event data was coming in. We want to be able to use that data, and we want to make everybody be able to use that data. So, usage includes analytics or reporting or visualization, this data can be used in pipelines. However the institution sees fit. And because it's an open infrastructure, we wanted to make it accessible to everybody, and so we did that with interoperability and open standards wherever possible. We use popular standards that are consumable by most organizations out there. So we used open software, open models, and processes whenever appropriate. Whatever anyone decides to do with this data or the visualizations, they can do so through open standards. So, what is the Open Learning Record Warehouse, the LRW? It's a standards-based learning record warehouse with support for learning, event, and supporting data. So supporting data can be really anything, but in this context, let's say it's rostering data, classes, and that sort of thing. And the learning event data is obviously events that are sparked by an institution, by an LMS, or by a tool, or by whatever's sparking those events. We implement it in Java 8. We use Spring Boot. It's mostly API-driven REST APIs. And we used a document NoSQL database MongoDB for the backend, and we'll talk about why those decisions were made in just a second. The key standards were IMS Caliper, XAPI, and IMS One Roster. So it's open for everybody. Anybody who knows those standards can make use of the LRW. The technical goals of the LRW were performance and scalability, storage, data security, and long-term archival, and differing formats. So the performance and scalability, we made it stateless, it's horizontally scalable. We use MongoDB, which allows for that horizontal scalability with replica sets. We strongly recommend using a hosted MongoDB service such as MongoDB Atlas unless you have MongoDB expertise and infrastructure in-house, or if you want to learn it, you can do that as well. So we use JWT API for security. It's technically multi-tenant, although currently it's not multi-tenant in a physical way. Tenants are still stored in the same database, so that's a direction that we're going to head in the future. The data at rest is we follow MongoDB best practices along for securing the data. For long-term storage and archival of this data, and it is a lot of data, it's event data for institutions, we tend to recommend that an institution should archive that data maybe in an S3 bucket or something like that. Every 3 semesters, maybe they rip off the events and store them somewhere. That's still being discussed and architected, and different institutions can do it in different ways. The data formats. For events, we can consume IMS Caliper. 1.0. 1.1 is available with a small code change. It wouldn't take very much to allow for 1.1, but we can't handle both of them at the same time right now. XAPI, the XAPI messages are essentially just translated into IMS Caliper 1.0. The supporting data that we use for courses, users, etc., we use IMS One Roster. Again, make it palatable for everybody, and then we use custom information where needed. So an institution might want to store grades and make that available to along with the data that we have, because that might be useful in analytics, that sort of thing. It's all available. That's the key standards we use. We use IMS Global because it's such a they've penetrated the market so well with their frameworks, and it's accessible to everybody. IMS Caliper was released in 2015, and it's used quite a bit, and it's solely focused on educational and learning use cases. So we also store XAPI, aka TinCan. If we consume XAPI, we actually store that data, we crunch it into IMS Caliper. So internally, the record store stores events as XAP, or sorry, as IMS Caliper. The differences are XAPI is really more generic and can be applied to use cases outside of learning, and IMS Caliper is really meant for learning data. As I said, Caliper messages, let me go back there. Caliper messages are stored as is, and XAPI messages are converted to Caliper prior to storage. IMS One Roster. The One Roster is just a subset or it's a profile of IMS LIS. And this allows us to store rostering information in a way that's widely used, and lots of folks already have infrastructures to handle IMS One Roster. So the key technologies here, for the LRW, we use Java 8 Spring Boot, heavy use of streams and map reduce features of Java 8 that allows us to do things a lot faster, follows Spring Boot conventions and best practices, and finally the LRW is packaged as an executable jar file, so you can just pull it down and configure it and run it. It's relatively quick and simple to get up and going. With Moodle, there's Moodle plugins that can write LMS, write Caliper events, and there's I think Sakai does, I think XAPI, correct me if I'm wrong, you can send me emails on that. And Canvas. Canvas has a way of sending event data directly to an AWS SQS queue, and that can just be written directly to the LRW. So MongoDB, we strongly recommend MongoDB as a service. We require version 3.4 plus. Production setup should include replica sets, encryption authorization, and et cetera, et cetera. So the infrastructure and deployment, load balancing, we handle HTTPS and SSL at termination. It's stateless, so no need for sticky sessions. We usually require at least 3 instances of LRW in production. That seems to be okay. And there's the sizing information if you like. This is only if you're running your own MongoDB cluster. So again, we still recommend that you would use a Mongo hosting service, but if you want to, you'd create your own instances of the production replica set. Deployment considerations. OpenLRW is packaged such that they can be run fully executable, and they can run as initd or systemd. So enhancements that we're looking for, support for database per tenant. As I said before, we are technically multi-tenant, but it's all in one database or one physical MongoDB instance. And we think that probably going forward, a full multi-tenant solution would allow for multiple tenant or a single tenant per database and physically separate them. Eventually, we want to support multiple versions of Caliper. Currently, only 1.0 is supported. With the use of Apereo libraries for events, 1.1 can easily be supported, but not together at the same time with 1.0. So we don't really have an admin interface. We're still technically young, and we don't have an admin screen, UX, or anything like that. And then we could slightly simplify configuration, although it's pretty simple at this point. So OpenLR improvements to the API. We'd like to develop generic query API. There's not a generic query API currently. You pretty much have to go with the APIs that are in OpenLRW. There isn't a whole lot of testing and automation quite yet. We're working on that. We're working on Dockerizing and that kind of stuff. And so that is the LRW. If you have any questions, feel free to give me a call or an email. Sorry, scody@unicon.now. I want to show you the visualization component of the LRW, and that looks like this. So let's do this here. This is the screen. It's launchable via LTI from any LMS. Currently, there is a student workflow or experience, but it hasn't been implemented in production yet. So really, we're talking about a teacher workflow here. The teacher would launch over from the LMS, and all of this stuff would be configured for the university and skinned. They'll select the class that they have, and in this case, this is all event data that we've been storing. In this case, we've also consumed risk scores from an analytics engine that made use of the APIs from the LRW. So over here, you'll see basic information about the course at the top. And then you'll see a graph here, which is we call the probability of success. This particular instance didn't have grades, but we've seen a graph similar to this where they put the actual grades. Each bubble represents a student, and the red indicates their probability of success. So these two students down here are doing pretty poorly. These two here are doing okay, and the green are all doing well. Here we have the roster, and you can do a whole bunch of stuff with the roster. So you can sort based on the current risk score that we consumed from the engine, and the number of activities they actually have. You'll see here on the right is a heat map of the events that the number of events that they performed on a particular day. So this bubble right here represents that this Tuco Salamanca did a whole bunch of work here on 125. And maybe a teacher would find that useful if there was a test there and they saw that Tuco was doing all of his work just before the actual test. We have a date range slider, so if a teacher wants to look into it and say, okay, show me just this date range, they can do that, and that's they found that pretty useful. We also have a drill down here where we can drill down into a user, so we'll drill down into Jesse Pinkman. Jesse Pinkman's doing okay. Again, we still have the header up here for the class. But then you see information here about Jesse. You still see his score, and but what you're seeing here in these graphs are different. They're answering different questions. This one's answering the question, when does this student do most of his work? So this student does most of their work on Friday. They do less work on Wednesday, and that kind of information we found is useful to instructors. The same with the activity by day of week. These are essentially the same graph. And incidentally, this is being displayed like this, but you can pick and choose which graphs you show and where you show them as well. I'm going to come down here and show the detail activity. This is like when they do a specific type. So on 2/15, Jesse Pinkman did, he completed a lot of two assignments. Yeah, and so that's useful. We have these other two graphs down here that display the the number of events compared with the course average. So we can see here that Jesse has submitted a lot more events than the course average. And we can see here they've shared a lot less events than the course average. And that information, again, has been quite useful. We can also see when Jesse's doing most of his work. And in this case, he's doing most of his work at 1 o'clock in the morning. I don't know why. Maybe he stays up really late. He gets home from work and does his homework. The other things that we've added here are filtering, so we can filter out specific events if we don't want to see submitted type events, and we don't want to see viewed type events, and we don't want to see searched type events. Maybe we don't care about logged in and logged out. That's one that people tend to configure to pull out. And then everything changes. We can also do a date information here, so we can choose the date information by narrowing the date type, and that's pretty much it. So again, my name is Steve Cody, and I work for Unicon. If you have any questions, or if you'd like us to help you get something like this up and going, please give me a call or an email, scody@unicon.net. Hey, thanks so much, and I hope you guys have a great day.